Good afternoon, guys. So we're doing 10.4 today, and we're actually going to go back to solving some equations. So that's always fun. But the difference here is that we're going to be solving quadratic equations, which we've actually never done before. So here's what a quadratic equation is. It doesn't look too much different than what we've seen. It's an equation that can be written in the form ax squared plus bx plus c equals 0. So we've seen quadratic functions so far a whole bunch. But this is an equation, finally, because it has an equal sign. And this is our standard form. So for example, they're going to give us questions that look like this. Hey, solve this equation, x squared plus 7x minus 8 equals 0. So you might be tempted to kind of start like manipulating this equation like we've done before. So maybe we should add 8 to both sides, right? Then we get x squared plus 7x equals 8. But then we have this issue. We're used to getting to a point where we just have like 7x equals and then some number, right? But we can't get just an x on this side. We can't add x squared plus 7x. If we subtract 7x from both sides, well, that still doesn't really help because now we have x's on two different sides. So we run into this issue because this x squared and this 7x can't be combined into just one term. So we are actually going to have to do something a little bit different to solve this that we've never done before. And there are several methods for how to solve quadratic equations. The first one that we're going to talk about today is graphing. But we're also going to learn these other three. We're also going to talk about taking square roots of both sides. We're going to talk about factoring it, and we're going to talk about using something called the quadratic formula. But like I said, this is the only one that we're doing today. These will be the next three sections that we do. So here is how you actually solve by graphing. You have three steps that you need to do. Step 1, ensure, so make sure that the equation equals 0. Step 2, graph the other side as a function. And step 3, our solutions are going to be the x-intercepts on the graph. And just beware, there are two other words that you might see used instead of x-intercepts. You could also call them roots, or you could also call them zeros. So make sure you have this written down. These mean the same thing as x-intercepts. So for this one, we're going back to that purple one. Just watch how I do this. So step 1 told me to make sure that the equation was set equal to 0. That's already done. It already equals 0. So good, I don't need to do step 1. Step 2 said graph the other side. So what I'm going to do is I'm going to take this side and I'm going to graph this as a function. So I'm going to graph y equals x squared plus 7x minus 8. I'm going to use Desmos to help me do that. Here we go. I graphed my function. And then step 3 said, well, the solutions are whatever your x-intercepts are. So remember, x-intercepts are wherever you cross the x-axis. This one is the x-axis. So I'm looking at where we cross the x-axis, and it actually happens twice. We cross it right here, and we cross it right here. So this makes sense, right? Because we were looking for where it equals 0. So we're looking for where the y's are 0. And both of these have a y equal to 0. And so what's the x in both of them? Well, this one, x equals 1. And on this one, x equals negative 8. So those are our two solutions, x equals 1 and x equals negative 8. All right, so x equals 1 and x equals negative 8. Now it wants me to check my solution algebraically. So I'm going to check it just like we did with all of our other equations. I'm going to take this one and I'm going to plug it in place for the x's and make sure that this equation is true. Okay, so at this point, all I've done was I replaced the x's with 1's. 1 squared plus 7 times 1. Now I'm going to multiply this out, do the math, make sure it works. Yep, I end up with 8 minus 8 equals 0. That's definitely true. Now I'll check the other one. There we go. So now I have my x's replaced with negative 8's, and I'm going to go ahead and do my math, make sure that this is true. Awesome, this one works out as well. So good, we checked both of our solutions and both of them work. Copy down example 1, and then let's do this one together. All right, step 1 said make sure it's equal to 0. It is, so we don't need to do anything for step 1. Step 2 says graph the other side like it's a function. So we're going to head over to Desmos and graph y equals x squared minus 10x minus 24. All right, we got it typed in. Now what do we do? Well, step 3 said your x-intercepts are your solutions. So I have 2 x-intercepts here. I have 1 here, and I have 1 here. And if you can't see exactly what they are, remember, click on them and Desmos will tell you. So they're -2, 0, and 12, 0. So the x's are -2 and 12. That means that x equals -2 and x equals 12. Now the directions say check your solutions algebraically. So we need to actually go and check them now. All right, so for each one, we're going to replace the x with whatever x we got. So the first one, I'm going to replace my x with -2. Notice that when I replace my -2 where x was, I keep that -2 in parentheses when I square it. You need parentheses around the -2 if you're going to square it. All right, and then -2 squared is 4. I have minus, well, 10 times -2 is going to be -20. So I can go back if I have minus -20, that's really plus 20. And then I have this minus 24 equals 0. Okay, 4 plus 20 is 24. Keep that minus 24, and sure enough, 24 minus 24 equals 0. Awesome. Let's do x equals 12 as well. Okay, 12 squared is 144. Minus, well, 10 times 12 is 120. Minus 24. And then 144 minus 120 is 24. Minus 24. Oh, yay. 24 minus 24 is 0. So check. They're both correct. Awesome. Go ahead and try example 2 on your own. Notice this one does not say you need to check your solution, so you don't need to plug it back in this time. You can, though, if you want to. And the solutions this time are n equals 3 and n equals -3. Now, you might remember from earlier in the year, we learned a symbol. If they're the same number but different signs, there's a little shortcut. You can save yourself about 3 seconds, and you can just say n equals positive or -3. So you could write that instead of the other two if you'd like to. All right, example 3. Go ahead and write it down. We'll do this one together, though. So the difference with example 3 is that step 1 is not already done. It said make sure it's set equal to 0. This one isn't. This one is set equal to 10. So how do we get this side to equal 0? Well, we have to get rid of this 10. We need to subtract 10 from both sides before we can do anything else. Make sure that you subtract 10 underneath your constant, your -6. So then on this side, I'll have x squared. Well, what's -6 minus 10? That's -16. Bring down your equals, and then this side is 0 now. Okay, sweet. Now we can just go ahead and graph this like we did before. Here's what we get when we graph it. We click on our 2 x-intercepts. We get 4 and -4. So we can use our fancy shortcut symbol, and we can say x equals positive or -4. Or you can write them out separately. It doesn't matter. All right, so I have a question for you guys. Will a quadratic equation always have 2 solutions? Those 3 examples that we saw, all of them had 2 solutions, but will that always be the case? Think about the graph and how we've seen our graphs look so far. And I wish I could hear your guys' answers. I really do, because I think you guys would probably have some really good ideas. But I just have to tell you, no, they're not always going to have 2 solutions. They might have 0 solutions. They might have 1 solution, or they might have 2 solutions. So for example, if this is our graph, we might have a parabola that only hits at one point and then just goes up from there. So this would be an example of one with just 1 solution. Or how could we have one with no solutions? Well, we could have one that just starts out up high. So it could start up here and then go up like this. This one never even touches the x-axis. So this one would have 0 solutions, and this one would have 1 solution. So I would add this tiny little sketch over here as well. All right, let's move on. So example 4 wants us to solve both of these equations by graphing. All right, let's do them both together. So 3x squared equals 0. It's already set equal to 0, so I'm going to go type in y equals 3x squared. You might at this point be so used to this that you know what this graph looks like. But if you're not, here's what it looks like. Y equals 3x squared. All right, it's hitting on the origin, that's our vertex, and it just goes up from there. So where are all the places where we hit the x-axis? Well, we only hit at one point right here. And what's the x? The x is 0, so this time x equals 0. This one we're not ready to graph yet because it's not set equal to 0, so we need to add 5 to both sides. So we get w squared plus 5 equals 0. Now we're going to go ahead and graph this. Now remember, Desmos doesn't know what to do if it's not an x, so change this variable into an x. So we have y equals x squared plus 5. And here's our parabola. Does this parabola ever hit the x-axis? No, it's never going to like loop back and come back down, right? We talked about that with our domain and range. So this one doesn't have any x-intercepts, so this one doesn't have any solutions. So we're going to write no solutions, or just no solution. Last one, try both of these on your own. When you unpause the video, I will have the answers up here for you. And here are our solutions. So again, we had one with no solution. This one never crossed the x-axis. This one did only at one point. Make sure, be careful when you're adding 25 to both sides. Negative 25 plus 25 is 0. So you just have x squared plus 0 on this side, which is just x squared. When you graph that, it looks like this. It only hits at one point. So your solution is x equals 0. Alrighty, that's it for this section.